Good day, everyone. Thank you very much for joining once again. So we are still continuing, and today we're going to do Euclidean geometry from your November 2022. That's your question 10 on your maths paper 2. Okay. Question 10, in the diagram, PQRS is a cyclic quad. KP is the tangent. P, C, and D are the points on the chord PQ. And PS respectively, and CD produced meet RS produced at A. So we are also given that CA is parallel to what? To QS, and they've indicated with those arrows that CA is parallel to QS. Okay, so they also tell you that angle P1 here is the same as angle what? Angle R2. Okay, then the first question 10.1, it says prove given reasons that angle S1, okay, angle S1 is the same as angle T2. Okay, so normally if you get these kind of questions that want you to prove that angles are equal, what you basically do is you go and check the angle that S1 is equal to using the theorems. So basically you check S1 and you check the angle that S1 is equal to, right? Then you also go and check the angle that T2 is equal to. So let's just assume angle S1 is equals to, I'm just gonna call this theta. Then angle T2 is equals to beta. Then after that, you go and check the relation between those two angles, right? You find that there's a relation that exists, and then at the end of the day, you'll find that they are equal. Therefore, you can conclude S1 is the same as T2 because both of them are equal to the same angle. Because those two angles in which each of them are equal to, they are also equal to one another. Okay, so basically, it's just the same approach with this. With these questions for you that requires you to prove that angles are equal. Okay, so we're gonna use that approach and see how it's gonna go, right? I'm just gonna first check what is my angle S1 is equal to. Okay, so from the given statement we are given that PQRS is a cyclic quad. Please note that the given information, they don't just give you, they know it's going to be very useful for you to answer. So all the given information in this statement just before the question, very important for us to, it's like it acts as a hint to enable us to answer this question. Okay, so they've given us that PQRS, and you can see the corners are in the circle. This is a what? Is a cyclic quad. Okay, meaning that our angle S1 here, it will be an exterior angle of a cyclic quad. What do we know? An exterior angle of a cyclic quad is equals to the opposite interior angle, meaning that angle S1 is equals to angle Q, which is actually angle Q1 plus angle Q2. What is our reason? Exterior angle of a cyclic quad, right? Some people might want to extend that reason to say exterior angle of cyclic quad equals to opposite interior angle. It's not a problem. Okay, now we got what our S1 is equal to. Okay, let us now go for T2 now. Okay, what is now T2 equal to? Maybe let me use a different color. We check what is my T2 equal to. Okay, you can see that someone can say actually T2 is also an exterior angle of this small triangle here. Okay, what do we know? Exterior angle of a triangle, what do we know about it? Exterior angle of a triangle is equals to the sum of the two opposite interior angles, right? Adjacent interior angles. So we can see that angle T2 will be the same as angle R2 plus angle what? Angle Q2 by what? Exterior angle of a triangle, Okay, we do know that exterior angle of a triangle is equals to, someone might want to extend it to say is equals to sum interior angle, right? Exterior angle of that small triangle there, the one in blue, this triangle, this is T2 is actually an exterior angle, is equals to the sum of the two opposite interior angle, that is the same as R2 plus what? Plus Q2. Okay, then after we have done this, we have found the angle that each of our angle is equal to. We can go and check the relationship between the two. Is there no relationship? And we can see that the relationship is actually quite there, because here we are finding Q2. Even in S1, there's an angle equals to Q2, meaning that it is left for us to go and check the relationship between what? Between Q1 and actually R2, whether they are equal. Okay, let's go and check. How can we find that relation, okay, between Q1 and R2? Because if we now find that R2 is the same as Q1, meaning that these two angles S1 and T2 will be equal to the same what? The same angle. Hence, we can prove they are equal. Okay. Okay, again, from the given information, we can see that with the R2, this one, R2, it has been given that is equal to what? Is equals to P1, right? Maybe we can write that. It can help us. We can say, but P1 is the same as R2, right? P1 is equals to R2, right? But we can see that we are given that there is a tangent KP, right? Somewhere here. Here is a tangent here. And we have our P1. But we can also deduce that this angle P1 is an angle between a tangent, because they said KP is a tangent, angle between a tangent and a chord, right? Then we can think of what? Tan-chord theorem. The angle between a tangent and a chord is equals to the angle subtended by the two other chords on the circumference. Okay, can you see? These are the two other chords that are coming from the same chord, right? So we can see that the angle between a tangent and a chord is equal to the angle subtended by the two other chords on the circumference, meaning we can think of what? Tan-chord theorem. Okay, then we can say, but again, we are finding that this P1 is an angle between a tangent and a chord there, right? Is equal to the angle subtended by the two other chords on the circumference. Okay, so meaning that our P1 is the same as angle what? This was given. We were given in the information, but this one, we can say this is what? From Tan-chord theorem. You can just say Tan-chord. Okay, meaning that we can therefore say, therefore, angle R2 is equals to what? Is equals to angle Q1, which was what we wanted to prove, so that these two angles can be equal now. Okay, why are we saying angle R2 is the same as Q1? It is because both of them are equals to angle what? Angle P1. Okay, therefore we can go and deduce, therefore angle S1 will be the same. Where there is Q1, I can go and replace by what? By R2. Okay, is the same as R2 plus Q2, right? Therefore we can deduce, actually now our S1 is the same as our what? As our T2. Why? Because both of them, they are equals to angle R2 plus Q2. Okay, both of them are equals to angle R2 plus Q2. So you can see that it's quite fairly simple to prove that angles are equal. What you basically do is, as I've explained, normally you go and check what is my S1 is equals to. That was our first step. Then we go and check what is my T2 is equals to, second step. Then you check the relation between those two angles. Okay, and we saw that actually Q2 is in both of them. It's just left for us to prove that Q1 is the same as R2, right? Then we go and check what is our R2 is equals to. We were given in the information is equals to R2, and we do know that P1 was equals to Q1 by what? By Tan-chord theorem. Okay, then we just use that and go and find the answer. Angle S1 is equals to angle T2. Okay, let's move to 10.2. 10.2. Okay, so before answering 10.2, it's really advisable that whatever angles that we have proven in the previous question as being equal, we just highlight them so that we can be able to answer the next question, because normally these questions are connected. Okay, so in the previous, we've just proven that angle S1 is the same as angle T2, right? And this T2 was, angle S1 was initially equals to angle Q by exterior angle, and we also proved that angle P1 is actually the same. I'm just gonna use black. P1, which is the same as R2, was also the same as Q1 by Tanco theorem. Okay, so now let's go to this question. It wants us to prove that the ratio of AD and AR is the same as the ratio between side AS and AC. Okay, so even with this question, it's called proving proportionality, right? Because if the ratios are the same, then the sides are in proportion. Okay, so we have a video on mastering proportionality to similarity questions. Okay, similar to these questions, where we really highlight how you can really approach them and master how to answer them. I'm just also gonna put that link in the description so that you can also go and watch it. Mastering proportionality questions, very fantastic session that we done, and you can just refer to it as well. Okay, so immediately when I see this proportion, same time it must come to your mind that in order to prove this, basically what you do is you go and identify two triangles that you can prove similarity, because from similarity we can move to proportionality from the theorem that we just did in grade 12. I'm just gonna put that link here in the description so that you can also go and watch it, because it's very, very important for you to conceptualize this question that's always there in most of the question paper, and it's just basic. It's a giveaway mark, right? So how can we prove this? Now what you normally do is you go and identify a triangle using the letters in the denominator there, and you also go and identify another triangle using the letters in your numerator. Okay, so I'm just gonna pick up the three letters in order, then I see if it's forming a triangle, right? If it's forming a triangle, then that's a tick, we can move. Okay, so let's check. A, D, A. Obviously this one form a triangle, right? Because you have two of the same letters. Even if we can go to the diagram and you check A, D, A, we are just forming a line. Can you see? It's not a triangle, meaning that won't work. Then we'll move to the other letter, the next one. So it will be ADS. Okay, let's go and check ADS. ADS. Yes, it's forming a triangle. Can you see? Let me highlight this in yellow. ADS. It's forming a what? A triangle. Okay, great. Then we can now go to the numerator and also identify three letters that can form a triangle, right? ARA. This one form because A is repeating, right? So let's choose another one. It's gonna be A. Let me use white. ARC. Okay, let's go and check ARC. ARC. It's forming that bigger triangle. Can you see? So I'm just also gonna highlight that maybe in blue. Okay, this one, let me highlight it in yellow just to show, and then the bigger one, ARC, just gonna highlight that in what? In blue. Okay, so we have identified two triangles on the numerator and on the denominator. What is next? You prove the similarity between these two triangles. So if you manage to prove that these two triangles are similar, then we can move from similarity to what? To proportion. I really encourage you to go and watch our session on mastering similarity to proportion questions so that you really conceptualize what we are saying right now, right? Because this is quite a very important question. Okay, so we are going to prove that in triangle, so I'm just going to say in triangle ADS and triangle what? ARC. In these two triangles, I'm just going to check the only two, right? Two angles that are equal between them. Then you can conclude the two triangles are what? Are similar. Okay, let's go and check. In triangle ASD, it's the one in yellow. Maybe let me use highlighter just to highlight this triangle in yellow, and the bigger triangle and the triangle what? ARC, this one, right? We're just gonna prove and check if they are similar then by just looking at two angles. Okay, already we can see something. Angle A, right? You can agree with me that angle A is actually common in both the smaller triangle and the bigger triangle in blue, right? So we can say we found one angle. Angle A is what? Is common. Okay, that's our first angle. Then we can move and check another one that is equal. Okay, so the second one won't be that easy, right? But let's go and check. Let's check in the small triangle angle S1. We have just proven that angle S1 is equals to angle T2, proven above, in 10.1, right? We have proven that. But angle T2 is actually the same, this one, T2 here. Maybe let me use a different color. The T2 is actually the same as this angle here, right? Which is STR. Okay, T2 is the same as angle STR, right? By what? Vertical opposite angles being equal, right? But this STR, this angle STR, we are given the two lines are parallel, right? Don't forget that this line here is parallel to this one, meaning that this STR, this angle, will be equals to this angle, corresponding angle, right? Because they are forming like an F or a T there, and these two lines are parallel. Okay, so we can say this STR is the same as what? As angle C2, which is in now the bigger triangle. So we were trying to get an angle in the smaller triangle that will be equals to an angle in the bigger triangle. Okay, so we can now conclude that actually our S1 in the smaller triangle will be the same as what? As S2. Why? Is because both of them, they're equals to what? T2, which is equals to what? Which is equals to STR. Okay, can you see? Both of them, they're equals to T2, which is the same as STR. That's why we are saying they are also equal. Okay, so we've gotten two angles that are equal between the two triangles. Therefore, we can conclude triangle ADS is congruent to triangle ARC. I know some of you might say, what about the third angle? We have to find three angles that are equal. Okay, normally you do that in possibly in grade 9 and all that. But in grade 12, we do know that the third angle will just be automatically equal by third angle of a triangle. You don't necessarily have to write it, right? You might write it if you want, but it's not really compulsory. Okay, so we can conclude that these two triangles are what? Are similar. Okay, the order matters in how you write these letters, right? So you write the letters according to how you also equated their angles. Okay, so we'll say angle, we started with A, triangle AS, then obviously it will be followed with D, is similar to triangle. Also A is common, we'll start with A, then followed with C this side, C, then there is R there, R. Okay, by what? Angle angle. Okay, so now we have proven that the two triangles are similar. What can we deduce? From similarity, we can move to proportionality. We have that theorem in grade 12 that if two triangles are similar, then their corresponding sides are also in the same what? In the same proportion. Okay, now that the two triangles are similar, we can go to proportionality. Okay, so how do we go to proportionality? From similarity, just take the two first letters, you make proportionality. So we'll say AS divided by AC will be the same as then the second one, the second last, SD over what? Over CR, which is the same. Then we take the first and the last, AD, first and the last, over AR. Okay. From similarity, we can just write this is from similarity. We can go to what? To proportion, or rather you can just say it is because triangle ASD is similar to triangle ACR. This implies proportionality. Okay, so that's our reason. It's because we are going to proportionality now because the two triangles have been proven that they are what? They are similar. Okay, so let's check what they wanted us to prove. They wanted us to prove that AD over AR is the same as AS over AC. And we have this here, right? AS over AC is the same as AD over DR. Therefore, we can conclude AS over AC is the same as AD over what? Over AR, because both of them are equals to SD over CR. Then we have proven what they wanted. So basically, with this kind of question for proving ratios, right, or for proving proportionality, what you basically do, if I have to repeat quickly, is that you go and identify your triangle on top, triangle below, prove similarity between them, then move from similarity to proportion. Also, just to conceptualize this deeply, go and watch again our session on mastering proving similarity to proportion. They are quite different questions that I put there, and they can really help you to conceptualize this. Okay, let's go to 10.3 now. Okay, 10.3, they want us to prove that AC multiplied by SD is the same as AR times TC. Okay, so if you can check on the page here, I've just put what we just deduced from 10.2. From similarity, we went to that proportionality there. Okay, it's because it's very important for you also to be writing this down on the side, whatever you proved in the previous question, so that you link it to the next question. It might be very easier to solve. Normally in Euclidean geometry, questions are interlinked, right? Whatever you have proven previously in the same diagram will also enable you to answer the next question. Okay, so we can just look and see that AC is also part of the side that we deduce from that similarity. Okay, SD also, you can see it from that similarity, and you can also see AR there. The only thing that is not there is what? Is TC. Okay, so that's the only thing that's not there. So what are we gonna do now is that we're gonna take those similarity and we're gonna cross multiply them, right? So we can see clearly that AC times SD, it will be equal to the first part there. Okay, then we can now go and try to prove the other one after cross multiplying. So the only one that we're gonna cross multiply is this one. So it's this part of that proportionality in 10.2, right? So when I write my 10.3 now, we're gonna say AS over AC is the same as SD over CR, and this is has been proven, right, from what? From similarity, from that similarity of that triangle, or someone can just write because triangle. We have proved above in 10.2 that triangle ASD is similar to triangle ACR. Okay, so we have already proven that, because we can see that when we cross multiply this, it will give us the first part there of what we have to prove, right? So we're just gonna cross multiply. We'll have AC multiplied by what? By SD is equals to AS multiplied by what? By CR. Okay, that is that. Then we can now go and check how can we now prove that AS times CR is the same as AR times what? Times TC. Okay. Okay, so we can actually prove this from this bigger triangle here. Can you see that we can use proportionality theorem that we learned in grade 12, right? That says if there's a line drawn parallel to one side of a triangle, that line will divide the other two sides such that the ratio of their sides of this side and this side will be the same or proportional. Okay, line drawn parallel to one side of a triangle, divide the other two sides of the triangle in the same proportion. It divides them in the same proportion. Therefore, we can now go and check, right? Remember, we want to now prove that CR times AS is equals to AR times TC, right? So let's go and check. CR is actually this bigger side here, right? So we can start with saying but CR over which side are we also interested in? We can go and check TR, right? Let's see. Okay, basically we can refer to this because this one is CR and AS, so it's actually this bigger one here, CR, and AS, which is the smaller one. So if we are saying CR, we'll also choose the other smaller one this side so that it will be proportional to AS there. Okay, so then I'll say CR over what? Over CT or TC will be the same. It's for this side, right? It's for this black side here. To say CR divided by TC will be the same as the bigger one this side, which is what? AR. Okay, so this is AR divided by the smaller one that side, right? Remember that is just a proportionality theorem. Okay, over AS, proportionality theorem. So you can just say proportionality theorem, and also because why? Because we were given that CA is parallel to QS. We are saying proportionality theorem can apply because the two sides were also parallel there. Okay, let me just delete so that you can also see that. Okay, so now we can now go and cross multiply, right? So if we cross multiply, you realize that CR multiplied by AS is the same as TC multiplied by what? By AR. We have just proven what we wanted. Remember, we wanted to prove that AS multiplied by CR, which is this, is the same as what? As TC multiplied by AR. Okay, so then we can now go and replace that AC multiplied by SD is now equals to what? It's now equals to TC multiplied by AR. Okay, because why? Both of them, they are equals to CR multiplied by AS. Okay, we have just proven that. So it's very easy for us to do this if you just recall the theorem that actually if there's a line drawn parallel to one side of a triangle, you have to think of proportionality theorem, and your choice of the side there are very, very important, because you must choose those sides that are proportional, obviously, such that they also correspond with what we want to prove. So that's basically how we do it. I hope you found this helpful. Okay.